Hello everyone. Welcome to Hydropower. Today, in this lecture we will talk about the sediment handling measures, the methods of bed load and suspended load handling in RoR Headworks. So, let's start with the sediment handling measures in RoR Hydropower Headworks. Sediment management is vital in RoR hydropower plants to prevent the accumulation of bed load and suspended load. Effective sediment handling helps maintain the efficiency of the intake structures and reduces the risk of damage to turbines and other equipment. Read on to learn about sediment handling techniques used in RoR Headworks, formulas used, and their derivations. Bed load handling. Bed load consists of particles, such as sand and gravel, that move along the riverbed. To manage bed load, RoR Headworks often use sediment retention basins or settling chambers. Retention basins. Sediment retention basins are designed to slow down water and allow bed load particles to settle. Settling chamber. A settling chamber may include baffles or weirs to facilitate sediment settling. They are typically located upstream of the intake structure. Formula. The formula used for calculation of settling velocity and retention time are shown here. Where G equals acceleration due to gravity, D equals diameter of the sediment particle. Mu equals dynamic viscosity of water. The retention time needed for particles to settle can be estimated using H equals depth of the sediment retention basin, V equals settling velocity. Derivations. Stokes' law and retention time formula help us estimate settling velocities and times to design and operate sediment management systems. Stokes' law describes the settling velocity of particles under the influence of gravity. It is derived from the balance between buoyant force and drag force on a particle. The retention time formula is derived by considering that particles will settle to the bottom of the basin at a constant velocity, these the time it takes for a particle to travel. The depth of the basin is given by T. Suspended load handling. Suspended load consists of fine particles that remain suspended in the water column. RoR Headworks use various methods to handle suspended load, including sediment exclusion and flow control. Sediment exclusion trash racks and screens prevent suspended particles from entering the intake. Flow control. Flow deflectors direct clean water toward the intake while allowing sediment-laden water to bypass it. Formula. The efficiency of a sediment exclusion device in removing suspended load can be calculated using the formula shown. G equals inflow rate of water with suspended load, CO equals outflow rate of clean water. Stokes' law and retention time derivation. Stokes' law calculates the settling velocity of particles under the influence of gravity. Bed load particles settle in sediment retention basins to reduce the risk of damage to turbines and other equipment. The derivation of Stokes' law and retention time is shown below. You can have a look. Where V equals settling velocity of the particle, R equals radius of the particle. Rho P equals density of the particle. Rho F equals density of the fluid. G equals acceleration due to gravity. Mu equals dynamic viscosity of the fluid. Sediment retention basins. Sediment retention basins are effective in handling bed load particles. The settling basin slows the flow of water and allows particles to settle to the bottom. The basin's depth and flow characteristics influence the settling time. Governing equations. The governing equations in sediment handling measures in RoR Hydropower Headworks are listed below. You can have a look on them. Flow control operational needs. Flow control fixtures minimize sediment buildup in turbines by directing clean water toward the intake structure. Likely threats. Damages to turbines, generators or transmission equipment caused by cavitation concerns, power interruption for maintenance work, and financial losses resulting from delayed restoration of electrical service. Flow control considerations. The flow control system's design must take into account the water velocity in the river, the amount of sediment, the available head, and the maximum backwater created by the fixture. Sediment management techniques. Bed load. Bed load consists of particles, such as sand and gravel, that move along the riverbed. Sediment retention basins and settling chambers are used to manage bed load. Suspended load. Suspended load consists of fine particles that remain in the water column. Sediment exclusion, trash racks, screens, and flow control can handle suspended load. Sediment exclusion device. Efficiency. The formula to calculate efficiency quantifies the percentage of suspended load removed by the sediment exclusion device. The efficiency formula is calculated based on the difference between inflow rate and outflow rate. Load reduction. Effective sediment exclusion at the intake means turbines and other equipment are functioning optimally and not subjected to wear and tear from high sediment levels. So this much for today. We will come again with new video. Till then, keep on watching our videos. Thank you.